In this video, I'd like to talk about identifying geometric solids, or in other words, we're looking at 3D shapes. So we're going to be given a picture and need to determine which of the options makes the most sense. So this shape right here, this is essentially just a box. And notice that all of the sides, the top, the bottom, the front, the back, and so on, these are all rectangles. And specifically, this is going to be a rectangular prism. So how do we know this is a prism, specifically rectangular? Well, a prism has a polygon as its base, so we can really call any of these sides the base. And the cross-sectional area, so if we were to make a cut in the middle of this, the cross-sectional area of a prism is the same along its length. So let's say we're looking at this front side as the base. And if we were to make a cut, let me use the line tool, along the length of it. So as we're heading back, then notice that the shape that we would cut out in the middle would have the exact same shape as that front face. And in fact, you can imagine in a prism that when you have your base, if you slide it backwards, it fits perfectly throughout the shape. So notice that the back face, the drawing's getting a little messy, but the back rectangle here, this would also be equal to the front rectangle. And like I mentioned, we didn't have to cut it this direction or use the front side as the base. We could use really any of these sides as the base. We could have used this as our base and then imagine sliding this rectangle backwards and it would fill in perfectly along the way since the front and the back rectangles are equal to each other. So if we had a cross section cut out here, it would also be the same size, and I'm not drawing this perfectly, but it would be the same size as this front rectangle. So that's a little bit off in perspective, but you can get the main idea. So that's the general idea of a rectangular prism. But prisms in general have everything to do with their base. So this would have a triangular base. And it has to do with that idea that if you cut it and look at the cross-sectional area, that it's the same along the length. So I want to show you a website that I really like. This is called Math is Fun. And with this website, let me zoom out a little bit. We have the definition of a prism. This one here is a pentagonal prism. It has a pentagon as its base. And you can imagine sliding that pentagon all the way through it. And if you were to cut it at any point, it would have a pentagon for that cross-sectional area. And if we look at a triangular prism, here's a nice animation where we can see we start with that triangular base and essentially you just slide it back, and that's one way to create these triangular prisms. So if we look at other examples, oh, and by the way, these prisms don't have curved sides. So this is a cylinder. This wouldn't be a prism. It almost is, but it has a circular base. So it's similar because that circular base can slide all the way through, and the bottom is the same size circular base. But prisms are made with polygons, not curved sides. So other examples, square prisms or rectangular prisms and cubes, but also you can see these triangular prisms or pentagonal prisms that we talked about, and you can see what their cross sections are. So prisms show up often in math, and it's important to be able to identify what they are. So imagine just taking one of the bases, and if you can slide it through, then if at the end you end up with the same size base, then that's a prism. Assuming that the base is a polygon. It's made from straight edges rather than curves. And since this has all rectangles, we know it's not a triangular prism. And we'll talk a little bit more about pyramids in the next video, but a pyramid essentially will have some type of base. So this one will have a square base. So let me quickly draw in a square base here with a little bit of perspective, so it's not going to look perfectly. And a pyramid is going to take every one of these corner points and have them all come together at one point above it. So it might not look perfect, but this would be a square pyramid. So it has some type of polygon base, and then all the corners come together at one point.